So we're going to be finding the distance between 2 points. Remember, we're doing coordinate geometry, so that means 2 points on the xy plane. Now, earlier in this topic, we looked at gradient, and this is actually really similar to gradient. I'll show you why. So if we remember, let's say we've got a line that looks like this. We've got a point here, which is like 3 across, 2 up. Let's say a point here, which is 4 back, and let's say 2 down. So we've got a point 3, 2, and -4, -2. So to find the gradient, what we did was we would draw in the run and the rise, and we'd have to work out how long each one of those are. So this one goes up 2 to get to here, and then another 2, so it's a total of 4 up, and between -4 and 3 is a distance of 7. And then we'd use rise over run, and so we'd get 4/7 in this case. However, when we're doing distance, you can see here what we've got is a right angled triangle. One of the shorter sides is 4, the other of the shorter sides is 7, and the distance between the 2 points that we've been given, the unknown value, that's supposed to be an x, sorry, is the hypotenuse. So we can use Pythagoras Theorem. So we could say the distance squared equals 4 squared plus 7 squared, which is, what's that, 55, 65. And so then the distance between them is the square root of 65, which will be like 8.06 at a guess. Something like that. I do have a calculator. Let's use it. Thank you. I'm pretty happy with myself. 8.06. So what we need to do then is work out a way of formalizing it. So to work out these distances using our gradient formula, we said y2 minus y1 over x2 minus x1. And that got us the distance from this y value to this y value. 2 minus -2 is 4. And it also got us this. 3 minus -4 is 7. So it got us the distance both times. So we're going to be using that to get the distance in the y's, that to get the distance in the x's. And you can see that they're used here and here. So we're going to be using those things. So let's write it out nice and formal and then have a go at using the formula. So distance equals the square root of, if you remember up here, we had to square root this thing at the end, so we're just doing it at the start this time. So distance equals the square root of x2 minus x1, the distance in horizontal, squared, plus y2 minus y1 squared. So 2 ways. Draw out your triangle, use Pythagoras Theorem, or the second way, which is just Pythagoras Theorem, but already put into the formula and already solved. So we're going to do an example using this second method. So let's say the question says something like, find the distance between the point, let's say, -3, 6, and 4, -5. Let's do that. Let me just move it over here, make it all on one line. There we go. So, first of all, let's write out our formula. And we can also label our points. Remember, it goes x first, then y. So x1, y1, and x2, y2. From there, it's pretty easy. We're just substituting 4 numbers on the calculator. Maybe that's a bit close to my last line. So x2 is 4 minus -3 all squared plus y2 minus y1, so -5 minus 6 all squared, which gives us the square root of, what would that be, 49 plus 121, so 160. Square root of 160, which would be like 12.7. So 160. 12.64. That was pretty close. No, 65 to 2 decimal places. So there we go. The distance between those 2 points is 12.65. Now, let's just quickly sketch to the side what this would have looked like if we had done this one. Let me just move the canvas a bit. What this would have looked like if we did it physically on the Cartesian plane. So we got back 3 up 6 for -3, 6, and across 4 down 5. So we would be finding the distance between those 2 points. So what we would have to do is draw the line connecting them, make it a right-angled triangle. Now what we did was we found the distance from all the way up here at 6, all the way down to -5 was 11. And the distance from -3 here to +4 there was 7. 11 squared plus 7 squared is 160. No, it's not. It's 170. Let me rub it out. Can I? No. Oh, yes, I can. So 170. And square root it. We get 13.04. That would have been closer because it's even closer to 169. And so then x, if we use Pythagoras Theorem, which is all we've done here, we would have got 13.04 to 2 decimal places. So either method is fine for you to use. I don't mind which. Obviously, this one's going to be quicker because it's not going to involve sketching, but this sketching one is going to, I think, physically make more sense to us, and we've already learned Pythagoras Theorem. So I'll put the exercises on Canvas for you to have a go at and see how you go.